Yes, Mr. Rudresh. Huh? On the graph of cumulative distribution function, it is a step function from minus infinite to plus infinite. Okay. So when we are talking about the coin, the coin toss, so k is equal to 0, k is equal to 1, k is equal to 2. And we can write like this one, and fx is given like this one, 0, 1, and 2. And fx we are mentioning here 1 by 4, 2 by 4, and 1 by 4. Is it the same example? So when we are talking about the fx, capital Fx, so capital Fx we are writing like this one, that is 0 when x is less than 0, because our point is started from 0 point here, okay? And then it will become 1 by 4 when it will become exactly 0. So 0 is less than x is less than 1. So till 1 it is 1 by 4. But suddenly then when it is x is reaching 1, that is equal to x, then we are adding these 2 points. So it will become 3 by 4. And it is up to 2. And then when we just suddenly reach to the 2, that point here 2, so equal to sign and x is like this one. And we adding the previous one like this one, 3 by 4 plus 1 by 4 here. So this is the total function which we can consider as a CDF of the. Now you can just make a graph. Here this is 0, this is 1, and this is 2. So before 0 it is 0. At we are reaching to 0, so it will start from 1 by 4. Just before the 1, it just step down, and when we are reaching 1, then it will become 3 by 4. So it is 1 by 4, 3 by 4. And then at x is equal to 2, it has become 1. So we can say it is 1 here. And up to infinity, it is become 1, 1, 1 here. Okay. So in the last class, we have defined yesterday class. Firstly, we have defined the total probability conditional law. I will just give you conditional law, conditional probability, then total probability law, and then we have done the Bayes theorem, Bayes law or Bayes theorem. Okay. After that, we have defined the random variable, then probability distribution, that is by using the probability density function, then CDF. Okay. So these 3 things we have done in the last class. Some more example we are taking today here. I already uploaded the slides of that. So we will just discuss it here. Then we can just move further. So one example we are taking here. A certain gas station has 6 pumps. Let X denote the number of pumps that are used in a particular time of day. Suppose the probability distribution of X is given like this one. So we can say this is the probability distribution which is given in the question, and we can verify that is a probability distribution or not, because we are just taking that all values are greater than equal to 0 and summation is equal to 1. Now what we are saying, the question is what? Find the probability that at most two pumps are in use. Two pumps are in use means probability when x is less than equal to 2 means either 0 or 1 or 2. Okay. Maximum number of pumps used in in use it's 2. So probability when x is less than equal to 2. So I am writing here probability when x is less than equal to 2 means what? Probability when x is equal to 0 plus probability when x is equal to 1 plus probability when x is equal to 2. Okay, so we are just adding these 3 points here, 0.05 plus 0.10 and 0.15, and the answer is 0.30. And this is, you can also consider as f of 2. F of 2 means what? The CDF. Because probability, CDF is what? Probability when x is less than equal to the small x. So here we can say it is denoted by the capital Fx. Okay, so we are doing the same thing here. And so this is F2 here. So this is the method that we are just adding these points. Firstly, this point, this point, this point, this point, and up to the end here. Got it? Now the next question is, find the probability that at least 3 pumps are in use. At least 3 pumps means what? 3 or more. Okay, so probability when x is greater than equal to 3. So it means what? Probability when x is equal to 3 plus probability when x is equal to 4 plus probability when x is equal to 5 plus probability of x is equal to 6. So this is more computed value. So what we will do? We can just change the formula and we can say 1 minus probability when x is less than equal to 2 here. Okay. Instead of addition of 1, 2, 3, we are just using the previous values to calculate it. You know, the summation should be equal to 1. You know very well. And minus this part. So if we are saying 1 minus of this part, then it will give 3, 4, 5, 6. So without addition, what you are saying, Mr. Prashant, in less than equal to 2, can we consider 0.20, 0.515? What are these values? I'm not able to get it. Less than equal to 0, less than equal to 2 means what? 0, 1 and 2. So 0.05, 0.10, 0.15. No, Miss Arpita, we are taking greater than equal to 3. So why we are adding 0, 1 and 2 and 3? We are adding 3, 4, 5, 6. Or we can use 1 minus of 0, 1 and 2. So 0, 1 and 2, that addition we have already calculated. So what we will do? 1 minus of the A part. So that will become 1 minus of 0 0.3, that is 0 0.70. Okay, that will become a more easy actually, because we are using the concept that summation should be equal to 1 for all. Okay. Next is find the probability that the number of pumps that in use is strictly between 2 and 5. So we are trying to find out the 2 and 5 and not including. No, we are not taking 0.152 times. This is the probability density function, and in the last class we have mentioned that fx at x is equal to 0 means what? Probability when x is equal to 0. Probability when x is equal to 1. Here it is a number of pumps. Here it is in use. So the probability when no pump is in use is 0.05. One pump is in use is 0.10. So this is the probability density function, or we can say the probability related to the different values of x. Yes, Mr. Venkata. That no pumps in use, that is the probability of no pump in use is 0.05. Okay. Now we have to find out the probability that 2 is less than x is less than 5. So what we are taking? Probability when x is equal to 3 plus probability of x is equal to 4. So we are adding here probability of 3 and 4. So it is 0.25 plus 0.20 here. So by using the probability mass for the probability density function, we can calculate. Mr. Malay, this is the probability. Probability is not equal to 0. Somewhere, some time will come when there is no pump in use. So why it is 0? There is some probability that no pump is working, no pump is running. It is a less probability, but it is a probability. It has some probability that no pump is in use. Okay, it is not 0. Correct, Mr. Vishnu. Correct, Mr. Vineet. Okay. The fourth part, then find the probability that the number of pump in use between 2 and 5. So that is the different here. They are saying strictly between 2 and 5. So we are not using the equality sign. So here we have to consider the equality sign and not equality sign. So it is 2 less than x is less than 5. So that is the probability when x is equal to 3 and x is equal to 4. But in the next one is the probability when 2 is less than x is less than equal to 5. Okay. So it is not strictly mentioned. There are so many situations when we can say that no pump is in use. All are working, but no customer is there. So we can say that it's a probability. It's a very less probability, but they are not in use. So in that one, we have to include the x is equal to 2 also. Probability when x is equal to 3 plus probability of x is equal to 4 plus probability when x is equal to 5. Okay. So we are including here 2 and 5 also, and that is 0.75. So we are just taking adding this one, that is 0.15 plus 0.25 plus 0.20 plus 0.15. That will become 0.75 here. It is given here strictly. That's the thing I just want to mention specifically here, that if it is we are mentioning strictly, then it means we are not including the extreme. But if it is not mentioned, it is between just a between 2 and 5. So we can use here 2 and 5 also. We include the 2 and 5 here. The next example, 6 lots of components are ready to be shipped by a certain supplier. The number of defective components in each lot is. So there are the 6 values here. Number of defectives they are mentioning here. Okay. X be the number of defectives in the select lot. Find F0, F1 and F2. So what we have to do? We have to find out the probability actually. So they are the mentioning the lot and number of defectives in that one. So you can say the number of defectives are either 0, 1 or 2. No, all are in use. That is the probability is 0.10, not 0.95. All 6 pumps are in use. The probability is 0.10. At least if we are saying at most 6 are using, then we are adding them. Okay. So X is varying from 0, 1 and 2 because there are we can say only 3 options here. Just a minute. I will firstly explain this question, then we will come back. Okay. So f of 0 means what? When there is no defective. So when there is no defective, you can see here 1, 2 and 3. So 3 times that is not defective. So that's why it is 3 by 6 here. F1. So F1 is 1 coming in the one lot only. So 1 by 6 here. And 2 is coming in the 2 lot. So it is 2 by 6. So the mass function or the probability density function we can write like this one. X is 0, 1, 2. And f of x is become here 0 is what? 3 by 6. And then it is 1 by 6 and it is 2 by 6. So this is the method to calculate the probability density function. And after that, if you know the probability density function, you can calculate any type of probability. So can you tell me the probability when x is less than equal to 1? So that is what? Probability when x is equal to 0 plus probability when x is equal to 1. And that is what? 3 by 6 plus 1 by 6. So it is 4 by 6 here. And that is what? F of 1, the cumulative distributed function at one point. So it is 4 by 6 here. Okay. Is it clear to all of you now, this question? X, fx. Fx is, x is what? 0. 0 are coming 3 times out of 6. So that's why it is 3 by 6. 1 is coming. Yes, you can write 2 by 6 as you can write is 1 by 3. No problem. Okay. So this is the way. Fx is equal to, Mr. Malaya, fx is equal to the probability when there is no pump is in use. X is equal to 0 means there is no pump in use. And there is a probability that 0.05 that there is no pump in use. Okay. So what I will explain in this question? Second part. Second part is what? I will explain in the slide like this one. So they are asking probability when x is less than equal to greater than equal to 3. So greater than equal to 3 means we have to just add this with 4, with 5 and with 6. Okay. That we can also do by another method, that all values 0 to 6 we are just adding and their value 1. So we can say 1 minus probability when x is less than equal to 2. So we are adding all the 3 values, all values, that is become 1. And then we can subtract this part for 1 and 2. Then it will give the value probability when x is greater than equal to 3. Both are different here. F1 is the probability, that is density function, and capital F means what? It's a cumulative distribution function. So F of 1 is equal to probability when x is equal to 1, and capital F of 1 is equal to what? Probability when x is less than equal to 1. At least 3 means the minimum is 3, correct? Okay, so that is the difference here. The CDF, this is known as the probability density function, and this is known as the probability cumulative distribution function. Okay, So after defining the this PDF and CDF, we are moving the ahead another concept that is known as the expected value or the mean value of a random variable. So mean value of a random variable, let x be discrete random variable of possible values of probability density function. The expected value of x denoted by expected value of x. It is expected value of x that is known as the mean value or average value. And that is what summation for all x, x into fx. Fx is what? Probability density function, which multiplied by x here. Okay. Last example, what we are just explaining in the last example. We have to find out the probability density function. In the probability density function, 0, the defective 0 is coming 3 times out of 6. So that's why the probability when x is equal to 0 is equal to 3 by 6. So that is the concept which we are using already in the last chapter to find out the probability of a different event. So here event is what? There is no defective. There is one defective and there is a 2 defective. We are trying to find out the probability which is given by using the given information only. That's clear. Similarly, one are coming only once at 4 plot. So that's why it is 1 by 6. 2 is coming twice. That is at 2 and 5th lot. So that's why it is 2 by 6 here. Okay. So the expected value of a random variable x can be defined as x multiplied by its probability density function, and we are taking summation for all values of x. Then it is known as the mean or expected value of the random variable x. It is a pure constant indicating the average value of x. Means what? As you have done in the statistics part, we have done the mean. Same thing we are doing here. But here mean value, that is the constant value, and that is the formula is different than the statistics part, which we have done earlier. Okay, so we can say x may not actually assume the same value. It is the mean value of that. Okay, now one example we are doing how we can calculate the mean. So an appliance dealer sells 3 different models of upright freezers having 13.5, 15.9 and 19.1 cubic feet of storage space respectively. Let X the amount of storage space purchased by the next customer to buy a freezer. Suppose X has a PMF, probability density function. This is PDF, that is the probability mass density function. Probability density function. Okay, that is we can say small fx. So that is also defined by the small px in some reference book or in your book also. Okay, so don't be confused. Small fx and small px are the same values. Now this is probability mass function is given here. Now this x is given, fx is given. Can you calculate the expected value of x? It is very x. It is what? X multiplied by fx, and we are taking the summation for all x. So now we are just taking here 13.5 multiplied by 0.2 plus 15.9 multiplied by 0.5 plus 19.1 multiplied by 0.3. The answer is coming here. So that is a direct formula you can apply to find out the expected value of x here. Is it clear to all of you? This is completely formula based. Actually here we are finding the expected value. So x multiplied it is probability density function, and we are taking the addition of all. Okay, I will show you 13.5 multiplied by 0.2 plus 15.9 multiplied by 0.5. 19.1 multiplied by 0.3. Similarly, we can find out the expected value of x square. So expected value of x square is what? We just taking the summation x square, whatever the variable is this, multiplied its probability density function here. Okay, summation for all x. So now what we are doing here, just go back. So it is equal to 13.5 x whole square multiplied by its density function plus 15.9 square multiplied by its density function, then plus 19.1 whole square multiplied by 0.3, and you can calculate this value on. That is the expected value of x square. Okay, so what we are saying here, whatever the variable in the formula, it is x square multiplied its density function, and then we can summation for all possible values of x here. Okay, so now you can also find out the expected value of x cube. What is the formula? We multiply x cube, we just x taking the cube of x multiplied by fx, and we are taking the summation for all. Okay, Mr. Vishnu? Okay, so this is just x and this is fx, and we multiply and we are taking the addition for all values. That is the formula actually. Okay, now B part of this question, if the price of a freezer having the capacity cubic feet is 25 multiplied by x minus 8.5, what is the expected price paid by the next customer to buy a freezer? So what we will do, what we are doing here, expected value of the price. So 25x minus 8.5. And by the linear property, we can write it like this one. 25 multiplied by e power x minus expected value of, or we can write in the other manner also, that expected value of 25 into x minus expected value of 8.5. X is the value of a random variable. Where we use it, where we are trying to find out the value, expected value of x, expected value of x square and expected value of x cube, then you are using these three things respectively. Okay, now in this one we are just using this part, and now we can just say this one is equal to the 25, the scalar is coming outside, expected value of x minus 8.5. The mean of a constant value is the same, 8.5. So now we can say it is 25 of 16.38 minus 8.5. So it is coming 401. Clear? So we can find out the expected value of any function of x by using the linear property. E represent the expected value of that function, of that random variable. 16.38 we have calculated earlier. Expected value of x in the A part. Okay, so we used it 25 multiplied by 16.38 minus 8.5, and then answer is coming 401. Clear? Expected value of x. Yes, this is the mean value. The mean of the customer will pay is 401. Correct. This is the constant value, and constant mean of the constant value is the same. Expected value of any constant, it is equal to the same constant. 16.38, which is given in the earlier, which we have already calculated, expected value of x in the A part. Okay. Now we are just taking another concept, that is the variance. Variance of a discrete random variable x. So mean, you know very well. In the earlier classes also we have discussed the mean. Mean we are just showing it the location parameter, and it will show you the central tendency. Okay. Now variance we are just talking about, that is the how much variate it from the mean. That is the definition. We have already discussed it earlier. Okay. So variance and standard deviation we are finding, it's not being measured by the mean. Okay. Variability. So which parameters must reflect consistency of the lack of it. How much consistent our data is, we can calculate it by the variance. If it is a less variance, then consistency is more. If it is a more variance, then we can say it is a data is not robust and it is not consistent. So the measure to assume a large positive value if the random variable fluctuates in the sense that it often assumes value for cluster from its mean. How far it is from mean, then we are just saying it is the large variability. Okay. So definition, now mathematical definition is, if mean is the mu which you have calculated as expected value, this is the expected value, this is also denoted by the mu. So we are saying the mean is what? The deviation from its mean. So that's why expected value of x minus mu whole square. Okay. So here what we will do, x minus mu whole square, and we are finding the expected value. And the standard deviation, which is denoted by sigma, it is the non-negative square root of variance of x. So firstly we calculate the variance of x, and then we can take the square root of the variance, that is known as the standard deviation. Okay, that part we have already done. Now we are saying it is always be non-negative value. If the variance of any random variable exists, then it always be non-negative value. It never be a negative value. Okay. Now in this one, we are just again explaining it here. Expected value of x minus mu whole square. So what is the formula? This is the function, and multiplied it by density function, and for summation for all values of x by the same formula of expected value. Okay. So here a very expected value of x minus mu whole square, that is known as the variance of x. Okay. Where mu is what? The mean. Got it? So this is the definition of the variance of a random variable here. Now we are saying that variance measure the dispersion of variability of x by considering x minus mu. Okay, we are just taking x minus mu. Somewhere it is negative, somewhere it is positive. Okay, so we are not emphasize on the sign. We just want the amount, how much variation is there. Okay, we are not seeing in the negative variation or positive variation, how much variation is there. So that's why we are taking the square of it, just to take the amount here. So the difference between the variable and its mean here, it is large if the value of x away from the mu have large probability. Okay, so mean is also coming same, large. Values of x are more likely to be spread. Okay, so it means x is spreaded out very large. That's why the variation is coming very large from its mean, and variance is also very large. So this indicates the inconsistency or instability of the random variable, because it is spreaded down very spreaded out in a large range specifically. Okay, that is the meaning. Now one other formula which is denoted by this variation to find out the variance. So one formula, as I told you here, that variance of x can be defined by the definition for all x, x minus mu whole square into density function fx. Okay, now we can say this is the definition formula and this is the computational formula to make it easy calculation. So what we will do, you can calculate expected value of x square and expected value of x. You have already done the mean and whole square. Okay, so that is the computation formula. There is a derivation of this formula also but we are not doing here. Okay, so derivation of this formula we are not doing here. And the formula for variance is this. Now you can easily calculate the variance specifically, because you can calculate the expected value of x square and you can calculate the expected value of x whole square. Okay, so now we can just move ahead and we can just use the same question and compute the variance of x. What is inverted A means what? Where? I'm not getting your question. Inverted A means what, Mr. Sanjeev, in the formula? Where is A? Capital A. I'm not getting here. It's mu. It's mu. Mu is what? Expected value of x. Okay, just opposite for A. This is for all. This sign is for all. So we can say here summation for all x. For all values of x, we have to take the summation. Okay. Okay, Mr. Vishnu. Yes, Mr. Mahendra. E9. Expected value of x square. Expected value of x square you have done already. That is what? Summation x square multiplied by fx. And this is for all x. For all possible values of x. We have to take the summation here. Okay. So variance of x, we have to compute. We have already calculated here in this formula expected value of x square and expected value of x. So direct this formula we can apply here. So expected value of x is 16.38. We have taken the previous example only. And expected value of x square we have calculated 272.298. So we are saying variance is 272.298 minus 16.38 whole square, and the variance is coming 3.9936. Direct formula. Okay. Now the question is the same here. What is the variance of the price paid? That is 25x minus 8.5. So variance of the 25x minus 8.5. So in this one, we are finding the rule that variance of ax plus b minus b is what? A square variance of x only. Because variance of b is what? B is what? A constant. And there is no variation in the constant. That's why the variance of b always be 0. So whatever it is plus, whatever it is minus, it's hardly matter for us. Plus 0, minus 0. So that's why we can say variance of 25x minus 8.5 is what? 25 square into variance of x. 25 square is 625 multiplied by variance of x. This is 2496 here. Variance of b is 0. variance of B is equal to 0 because B is a constant and there is no variation in the constant. Variation is coming if they are having the different values. Okay. How 25 square? Because this is the formula we are taking here, that this formula, that a square variance of x, because variance of x is coming in the square form. If you remember the definition, so we are taking the square form. That's why the constant which we are taking outside, we are taking the square of it. Okay. So this is 2496. In the same example, we can find out the expected value of x, the mean, expected value of x square, then variance of x here. Okay. And we can find out the variance of, yes, a is equal to 25. Ax minus b, it is given. A is equal to 25, b is 8.5. Is it clear to all of you? Any doubt, any query to find out the mean and variance? Direct formula based, you have to just use the concept expected value of x. I wrote so many times the formula for expected value of x square, and these use of expected value of x square and expected value of x, you can find out the variance. And similarly, you can apply the formula for variance of any function like ax plus b. So in the previous question, we have done expected value of ax plus b. Here we are doing variance of ax plus b or ax minus b here. Okay. So any function in the linear form that we can also use here. Got it? Any query? How variance is 3.9 coming? By the formula only. It is given on this one. You can calculate by your own also. Okay. Is it clear to all of you? Where we are taking 16.38 whole square? We are not taking 16.38 whole square. Is this here? Here in this case, it is, I already gave you the formula here. Expected value of x square minus expected value of x whole square. This is the computational formula of variance. That's why, Mr. Akshay, it is 16.38 whole square. Okay. So I am just taking the break. Please try to do these questions. And if you have any query, then we will discuss later on after the break. And then we will start the. After that, we will start the new concept, that is the section 4.2, that is the binomial distribution. Okay, that is a specific distribution. So till now we were discussing about the general distribution, that any x, then we can find out its probability density function, then we can find out the CDF, we can find out its mean, its variance, and its any type of probability. That's we have done. Now by using the same concept, we can find out, okay, the general specific distribution and its mean, its variance, its different type of probability density function, any type of probability, that we will discuss after the break. Thank you. Welcome you back after break. Slides are visible? Are the slides visible? Okay, thank you. Thank you. Thank you so much. So we have done, again I am summarize all the things. So we have done the random variable. What are the random variables? We have done is the probability density function. We have done the CDF, the cumulative distribution function. After that, we have started the mean. We have done the variance and the different type of probabilities by using the PDF and CDF, the probabilities. So that we have done till now for this chapter. Okay. For any distribution means what? X having any probability density function here. Clear? Yes, Mr. Vishnu, you have some query? Actually, I'm not. Yes, Mr. Vishnu. Okay, thank you. Thank you so much. So after that, after this summarization, now we can just move further. That is the specific distribution, which is known as the important discrete distribution. So first is we are taking about the that is the section 4.2 in your textbook. That is the binomial distribution. Okay. Before binomial distribution, we have to define a Bernoulli trials. So what are the Bernoulli trials? Which have only two outputs, two possible outcomes. That experiment is known as the Bernoulli trial. Two outputs means tossing a coin, either head or tail. Okay. Attendance of the students, either attending or not attending. Okay. Rolling a die, even number or not even number. Okay. Either success or failure. Okay. So that case is, we can say, is the Bernoulli trial. And Bernoulli trial, when we are taking the experiment, it follows the Bernoulli distribution. So X having only the two values, 0 and 1. Okay. So density function, we can say for success it is P. Let us suppose it is P. So it is what? 1 minus P, because P plus 1 minus P, it should be equal to 1. Okay. So that's why if it is P, so it is 1 minus P. You can also find out the expected value of X. Expected value of X is coming what? 0 multiplied by 1 minus P plus 1 multiplied by P. So it is coming P here. So we can say X is a Bernoulli trial, random variable of Bernoulli trial. It having the Bernoulli distribution with parameter P actually. Here this is important thing, that parameter P. Because here we are assuming by ourselves, then expected value of X is known as P here. You can also find out the variance. How you can find out? Again, we are taking one example, expected value of X square. How we can say 0 square multiplied by 1 minus P plus 1 square multiplied by P. So that is also P. Okay. So if you know the expected value of X square is equal to P, and this, the variance is what? P minus P square. Okay. P minus P square. So we can just take its P common. So 1 minus P. So it is PQ. Q is what? 1 minus P. So there is a Bernoulli trials basically. It is also provided in the slides. Don't worry about it, Mr. Vineet. Okay. So there are common features to each of the examples. They are all composed of a series of trials which is referred to as Bernoulli trials. Okay. And having the following assumptions. So there is only two possible outcomes for each trial. I already told you success or failure without inferring that a success is necessarily desirable. Okay. Either success or failure. The probability of success is the same for each trial. Say we are saying P. Probability of success for each trial is same. They are not making a changes actually. And the outcome from different trials are independent to each other. If we are just doing the Bernoulli trial, only one time we are tossing a coin. That is Bernoulli distribution. But if we are tossing a coin 5 times, so at a time, all time the whatever the outcome is coming, that is the independent of each other. Okay. Then we can say here we are just doing a n Bernoulli trials. Okay. So we are just doing the 5 times we are tossing a coin. Tossing a coin is a Bernoulli trial. You know, either success or failure, whatever it is. Okay. So in that case, we are just using it's a Bernoulli binomial distribution. So let P be the probability of success. Okay. And Q is what? 1 minus P for the probability of failure. So if P is the probability of success, so failure is what? 1 minus P. That is also denoted by the Q of a random experiment X. Denote the number. X is the what? Number of success among the n number of independent trials. Okay. So n number of Bernoulli trials we are doing, and X is the number of success out of n trials. Okay. It may be 0, 1, 2, 3 up to n. So we can say X follows the binomial distribution with the probability density function fx is equal to this. Okay, that is n factorial upon x factorial up into 1 n minus x factorial p to the power x q to the power n minus x. Okay, and we denote that x follows the binomial distribution with x, and the parameters are n and p. We have to know that how many trials we are doing, and we have to know about the what is the probability of getting success. Okay. So if we know the probability of getting success, we can also calculate the probability of failure. That is 1 minus P. Okay. For all values of X, belongs to Sx, means for all X is equal to 0, 1, 2 up to n here. Okay. X is a random variable and small x denote the particular value of the random variable. N and P are the parameter, that is fixed real numbers. Firstly, we fix the experiment that we have to toss a coin 5 times. So here n is equal to 5. What is the probability of getting success if we consider success is head? Can you tell me, any one of the student, what is the small value of small p value? Probability of getting success when we are tossing a coin, and success is we can consider as head. Why, Mr. Sanjeev, it is 1? It is 1 by 2. Correct, Mr. Sandeep. 1 by 2. Okay. Probability of getting success, either head or tail. So it is 1 by 2 here. Okay. So here we can say n is 5, p is what? 1 by 2. So that is a fixed if we decide our experiment. And when we are substituting in this formula, then will become the different density function. So from this case, if we identify that x follows, this random variable follows the binomial distribution, then there is no need to calculate just like a probability. Directly by using the fx, you can use the probability density function, and by direct formula you can make the table of the probability density function. Okay. Like example we are taking here, if x is the number of heads obtained in 3 flips of the balanced coin. So here n is equal to what? 3. P is equal to 1 by 2 here, number of heads. So P is equal to half, n is equal to 3, and x follows the binomial distribution with the x, n is equal to 3 and P is equal to half. And x can vary from success may be no success, one success, two success, and 3 coins only. We have to flip a 3 coins. So maximum success is 3 times. Okay. Now, when we defining this one, we can also find out the density function. So f at x is equal to 0 is 3 factorial upon 0 factorial, 3 factorial, 1 by 2 to the power 0, 1 by 2 to the power 3, it is equal to 1 by 8. Okay. F of 1 is small x. I'm not audible? Mr. Malay, I'm not audible? Small x means what? Audible. Okay, thank you. Small x is means what? That different values of capital X. Capital X is the random variable. I already told you earlier. Capital X is the random variable and its possible values are denoted by the small x. The small x may be 0, 1, 2, and 3. Okay, so we can use the formula here, this formula, just for finding the probability density function. Okay, so now you can say it is 1 by 8, it is 3 by 8, it is 3 by 8, it is 1 by 8. So you can write here x 0, 1, 2, and 3. So fx will become here 1 by 8, 3 by 8, 3 by 8, and 1 by 8. Okay. Yes, correct. 3 factorial, 1 factorial, it is 2 factorial. Correct. Thank you. Thank you. I will change it. And in the F2, it is 2 factorial and 1 factorial. Correct. Thank you. Thank you, Mr. Malay. Thank you, Mr. Mahindra. In the 3 flip, there is a success, no success, no head is coming, 1 head is coming, 2 head is coming, 3 head is coming. Because in the all 3 flaps, we are not getting any time head. X, you just check the X. We are not, X is the flip, number of flips. Mr. Sanjeev, okay? We are just using the X is the number of head which is coming. So out of 3, that is the possibility that no head is coming. So that's why it is 0 included. Number of head, X is the number of head. Yes, number of success. Okay. So now we can just use this x and fx and we can find out the expected value of x. X multiplied by x summation for x is equal to 0 to 3. So 0 multiplied by f0, 1 multiplied by f1, 2 multiplied by f2, 3 multiplied by f3. And the answer is 3 by 2. What is the power x? Here 1 by 2x and 1 by 2 to the power n minus x. This is the formula of the binomial distribution. And the derivation of the formula is it not in your syllabus. It is little bit involving so much mathematics. The binomial theory we have to apply. Okay, so we are not using the formula here. Similarly, we can find out expected value of x square, that is the x square into fx. Summation x is equal to 0 to 3, 1 square f1 plus 2. This is not 2 square f2 plus 3 square f3. It is equal to 3. Okay, so variance of x is equal to 3 minus 3 by 2 whole square. So that is 3 by 4. Okay. So what we are saying that if x follows the binomial distribution with parameter n and p, then the density function is defined by this and the mean is np. So that formula again we are just derive it, which we are not doing here. It's a lengthy process to calculate the expected value of x and p. So what is the benefit here? In the previous example, we have calculated by using the formula. But if we know it follows the binomial distribution, there is no need to calculate it by the so much lengthy calculation. Directly we are saying NP. N is equal to 3, P is equal to half. So what we are saying, expected value of X is equal to NP, that is 3 into 1 by 2. Variance is NPQ. So variance of X is equal to here that NPQ. N is equal to 3, P is equal to 1 by 2, Q is also 1 by 2. So it is 3 by 4. So it is 3 by 4. Okay, that is the benefit of finding that okay, it follows this random variable follows binomial distribution. So directly without so much calculation, we can calculate the mean and variance. Are you getting my point here? Any query? Just give me a 1 minute. I have to take the water. Just give me 1 second. Q is equal to 1 P 1 minus P. That's very good that I am taking the water and this you are You are discussing all the things. I can see in the chat. Whenever you required my notes, you can see the recordings, because recordings are also available, and in the recording you can find out all the this particular slide. So don't worry about it. In the recording you will get everything. Am I audible to all of you? Thank you. Thank you so much. Firstly, we will just do one example. Oh. Okay, fine. Actually, it is not my hand to just to allow you to download recording. Actually, I'm also not able to download it. I can only see. I am not able to download our recording. So now come to the one example here. Okay, Mr. Vineet. One example here. The College Board reports that 2% of the 2 million high school students. I am not uploading my notes because they are not in the proper manner. I am writing just to explain it. Somewhere it is cutting, somewhere I am just writing somewhere else. So it will create the confusion only. That's why I'm not uploading the notes here. You can see I am just writing because of the time problem, because of the lack of space. I am writing the answer is here 3/4. So later on, now it's okay for you, but later on when you're just seeing these notes, it is looking very absurd, very weird actually, that what we are doing here. Okay, Mr. Amol. I'm trying to write it in the PPT, but that will not save actually. Come to the example. The College Board reports that 2% of the 2 million high school students, so 2% of the 2 million high school students who take the set each year receive special accommodations because of documented disability. Consider a random sample of 25 students who have recently taken the test. Okay, so here 25 students, we are doing the trial, and the probability of getting success, that means who are just receive the accommodation. So that is 2%. That is the probability of getting success is 0.02 here. Okay, now no, answer is not 2% of 1/25 here. It is the probability that exactly one received a special accommodation. Exactly one. So it means we have to find out the density function probability at x is equal to 1 here. Okay. And x is what? X is the number of students who are receiving the taken the test and then receiving the accommodation. So x is equal to follows the binomial distribution with parameter n is equal to 25 and p is equal to 0.25 or 0.2. Okay. So now you have to find out probability what x is equal to 1. That is by using the probability density function. What is that probability density function? 25 factorial upon r factorial, that is here 25 sorry, 1 minute. It is 1 factorial, 24 factorial, and multiplied by 0.02 to the power 1, multiplied by 0.02 to the power 24. Sorry, not at 0.02. It is 0.08, 1 minus p to the power n minus x. N minus x is 24. Okay, so you can see here the answer. X follows the binomial distribution with parameter n is equal to 25 and p to the power p is 0.025. The probability exactly 1 is what? NCX, that is 25. This value is become 25, 0.2 to the power 1 and 0.98 to the power 0.98 to the power 24 here. Now it's clear to all of you. Meaning of 0.2 is means probability of getting success 0.202. It's not 0.2, 0.02. 2% success. It is given. The report that 2% of the 2 million high school students who take the set each year receive the special accommodations. Special accommodations. In the PPT, it is given the formula. And because here it is given that 25 students are taken and we are just taking either success or failure. They are identical to each other. X denoting the number of success out of n trials. So that's why X follows the binomial distribution. I told you that earlier 3-4 properties of the binomial distribution case. So X is the number of success out of n trials. Bernoulli trials, either success or failure, getting received the accommodation or not received the accommodation. Second is their probability of getting success is same for all, and they are independent to each other. It doesn't mean that, okay, I will give you the first student, so I will also give for the second student. They are randomly giving it. Okay, they are independent to each other. Okay, now what is the probability that at least one? So which what you are saying, at least one, x is greater than equal to 1. How you can calculate x is greater than 1? Probability when x is greater than 1. I already told you 1 to up to 25. We have to move. So what? It is very easy. 1 minus probability when x is less than equal to 0. Okay. So in this one, what means what? Please explain why x is equal to 1. It is given in the question that exactly 1 received it. Okay. Next is the x is greater than 1. So we can say it is this. So it is what? 1 minus n factorial, 25 factorial upon n x factorial, n minus x factorial 0.02 to the power 0, 0.98 to the power 25. Okay. So that is the answer. 1 minus probability when x is equal to 0. So it is 1 minus 0.98. It will become 1. It will become 1. So it is 0.98 to the power 25 and it is the answer is 0.397 here. 0 factorial is not equal to 0 factorial we are taking as 1. C part, what is the probability that at least 2 received a special accommodation? At least 2 means what? Probability when x is greater than equal to 2. So probability when x is greater than equal to 2 means what? 1 minus probability when x is less than equal to 1. Probability when x is equal to 1 is what? 1 minus probability when x is equal to 0 minus, or you can say like this one, probability when x is equal to 1. When we take less than 0, it is means only 0. Okay. So x is greater than 0 means 1 minus x is equal to 0 and x is equal to 1. This is wrong, I believe. It is 1 minus x is equal to 0, 0.603. That's 0.308. Okay. Now D part. What is the probability that the number among the 25 who received a special accommodation is within 2 standard deviation of the number you would expect to accommodate? Within the 2 standard deviation of the number you would expect. Okay. So firstly, we have to calculate the standard deviation. So x bar we are finding, that is what? Expected value of x is what? NP in this case. So it is NP is 20 multiplied by 0.02. So it is 0.5. So standard deviation is what? Square root of NPQ. So it is 0.7. So they're just asking about the question. Just go to the question. Within 2 standard deviations. So 2 multiplied by standard deviation. So it is x bar plus minus plus of 2 standard deviation here. Okay. So it is 1.9 and x bar minus 2 sigma. So that is become here 0.5 minus 2 multiplied by 0.7 and that is coming less than 1 0. So that's why minus. So it is become 0 because x is varying from 0 to 1.9 and 1.9 means what? It is up to 1 only because 2 is not included. So probability when x is equal to 1 and 0. So it is equal to the probability when x is equal to 0 plus x probability when x is equal to 1. So it is 0.70 less than equal to 1. So it is 0.705. We have already done this part. Now at the E part, suppose that a student who does not receive a special accommodation is allowed 3 hours of the exam, whereas an accommodation student is allowed 4.5 hours. What would you expect the average time allowed for 25 selected students to be? So 0.5 expected value for 4.5, 24.5 multiplied by 3 and divided by 25. So expected value, the mean, arithmetic mean we are talking about here. So it is 3 hours, 3.03 hours here. In this one, we have to find out the standard deviation. Okay, standard deviation is coming here 0.7. I am just explaining here. Okay, so standard deviation is coming here 0.7. Clear? Now they are saying what is the among the of the number you would expect to be accommodated. What is the probability? So we have to probability, we have to basically probability, standard deviation we can find out. Now standard deviation is what? Square root of the variance. Variance of x. Variance of x is what? NPQ. So n is 25, p is 0.02, q is 0.98. And taking the square root. So that is coming 0.7 according to the question. You can see in the slides. So it is 0.7. Okay. So now we have to just use here within the standard deviation. So it is x bar, that is the mean, plus minus 2 sigma. Okay. So x bar plus 2 sigma is become here. X bar is 0.5 plus 2 multiplied by 0.7. So it is 0.5 plus 1.4. So it is 1.9. X bar minus 2 sigma. It is 0.5 minus 1.4. So it is minus 0.9. So minus 0.9 is not possible for x value. X is starting from 0. So we can just take here x is varying from 0 to x and it is up to 1.9. So 1.9 means what? Up to 1 only, because these are discrete value. So that's why we are taking their probability between 0 to 1.9 is what? Probability when x is equal to 0 plus probability when x is equal to 1. Because next probability is coming at x is equal to 2, which is not included here. Okay, so it is given within 2 standard deviation of the number you would expect to be accommodated. Because we are finding the range within 2 standard deviation of the number. So x bar plus minus 2 sigma. Sigma is the standard deviation of the 2 sigma standard deviation here. Point 0.5 is the mean. X bar. Yes, we are finding the formula of the range basically x bar plus minus 2 sigma, which is given in the question within 2 standard deviation. 2 multiplied by standard deviation from its mean. So x bar plus minus 2 sigma. Is it okay for all students? So I'm just trying to summarize today's work because I'm not going some more values because again it will difficult for you to understand it. The next distributions in the next class we will do more distribution here. So we have done the random variable, their PDF, their CDF, different type of probabilities, then mean, then variance, and we have done the binomial distribution. So in the binomial distribution, we are finding their PDF, their mean, their variance, and how we can identify probability in this range specifically, Mr. Bishnu. E part, suppose that a student who does not receive a special accommodation is allowed. Okay, who doesn't receive a special accommodation is allowed 3 hours for the exam, whereas an accommodated student is allowed 4.5 hours. Okay. So average time allowed for 25 students. Average time of this 25 students, they're just mentioning here 0.5. The students who are attending, average number of students who are receiving the accommodation. You have done its 0.5, expected value of x. This is 0.5 multiplied by 4.5. This time allow for the students who have received the accommodation. But 1 minus expected 24 is 25 students, but mean 0.5. So 1 minus mean is 24.5 who are not receiving the accommodation, multiplied by 3 hours. They can allow for the 3 hours only, divided by 25 here. So it is the mean value of the time that they can allow in this one. Okay. So that is coming 3.03 hours specifically here. So now, yes, Mr. Vishnu. Yes, Mr. Vishnu. I allowed you the for mic.
Yes, ma'am. Yeah. Good morning.
Good
And
morning.
thank you, ma'am, for allowing the mic. Ma'am, just one thing I want to say, ma'am. Whatever topics we have covered till now for this fifth session, can you please give some questions for each topic so that it will be easy for us to understand what type of questions will be for the each topic? Will that
Okay,
be
you
possible
like
for you?
you are saying just making a tutorial sheet type of thing for practice purpose.
Yes, yes. Means let us say today means you have covered PDF, CDF, mean. So it will be good if you can identify the questions, what type of questions will be related to this topic. Okay. Because no, what is happening, we are not understanding, means is it really from which it is coming, what type of question it is. So it will be easy for us to understand that one.
What type of question is coming in the examination? You can see from the previous year question paper, which is already uploaded on the eLearn portal. One thing. Second
That is
thing,
correct, ma'am. Yeah.
second thing is what? That I am not giving you the practice questions because it's okay for you. I don't know. But I know that most of the students having a less time. So they just do only the practice purpose questions, only one question or two question for each type of things which I will provide as a practice question. But I want that please go through the test book, do at least 3-4 types of questions so that at the time of examination you can avoid any type of confusion. Okay, so same type I will just showing you by using the section number, and you can open your book and you can find out several practice purpose questions, same type of questions.
Okay.
Okay, so that is my point of view. Otherwise I will provide you questions, no problem for me. Okay, but I that is my experience only, that if I will provide some question sheets for practice purpose, most of the students are doing only these questions, and which is very limited, and that will create the confusion at the time of examination because it's a mathematical course, and if you are doing only one or two questions for each type, it's very difficult to do this part in the examination. That is my point only. है ना? I believe and I always suggest you that please do the practice, at least 4-5 questions of each type of things. Binomial distribution, then you can identify, okay, this is a binomial distribution and how we can calculate the formula. So there, if you're doing 4-5 questions now, so then there is no need to remember the formula as well. It's very difficult to remember the formula, definitely, I know. But
Yeah,
if
ma'am.
you are
Yeah.
just doing the practice, 4-5 questions you will do, so at a time that formula is it is coming in your unconscious mind, directly you can use it.
Yes, ma'am. You're correct. Absolutely right, ma'am. Just actually, if you can give some questions, no, we will, of course, we will go for the another questions. Once we practice it, no, then we can go through the book and we can practice more questions. But at least, no, so that no topic wise we'll understand what type of questions is this. for this topic, particular topic. Let us say PDF. It is a for PDF. What type of question is this? So that we will relate it in the book and we can practice more questions. That is what the intention is exactly. So
I can
that
understand
supports
your
me.
point. I can understand your point, but
Yeah, yeah.
you can also try to understand my point. I am not just talking about the 83 students who are attending the classes. There are 400 students are attending, are enrolled in this class, and students are also not attending the classes. Only 83, 84 strength is there. I know that 84 students, I believe that 84 students are doing the practice from the book as well, and the practice purpose questions. But what about the other students? We are also thinking about the other students who are not attending the class, who are not, and I'm not saying that intentionally they are not attending the class. They may be having some problem or some other assignments, important assignments. That's why they are not able to attend the class. So we have to think about all the students. Okay, for all other student point of view of the all other students as well. So I'm just trying to give you, no problem. I will try to give you the questions, 2-3
Yes,
questions
ma'am.
for each type of topics. I will
Yeah.
upload on the eLearn portal. Don't worry about it. Okay.
Yes.
So
Yes,
I will
ma'am.
do it, but please give me some more time for making this question papers.
Okay, no problem. No, no. Means it can be random. Means you can put in notes also, like you're writing a note. No, that will be also fine for us. Just we have to follow that one. That's it. It will be only for practice. It is not like that. It is going to come. Something is going to come from that. It's only for our practice only.
Yes, I
That's it.
know. I understand your problem also.
Yeah.
Your point of view also I can understand, but I will try to do it. I will upload in the PDF file, but please give me some more time that I will make the questions and I will upload it.
Yes, ma'am. Yes, ma'am.
Okay.
And last question, ma'am. In the E is there is a formula for this, ma'am. This arithmetic mean.
Is the arithmetic mean simple? They are just asking for the time hours, how much mean time hours we are just giving to the students. So that's why it is a sample. So we are using a statistics formula, arithmetic mean we are taking here. That is basically not the arithmetic mean, even we can say it is a weighted sum specifically, no? 0.5, that is the giving time is 4.5 hours and 3 hours. But we are giving the weights to the that expected value of that x, that is 0.5 and 24.5.
Okay. Okay. Got
Uh,
it.
which formula you are using, actually that's the important thing, that read the question carefully. Please read the question carefully, and then based on that you just identify that which distribution is this, what is the random variable, what is the distribution of that random variable, then what formula we have to apply, what is asked basically. 0.5 is the expected value of x, and they are applying to just for the 4.5 hours who received the accommodation. And we can say here 24.5, 24.5 is what? That is the expected mean who are not receiving the accommodation. They allow only for 3 hours. So we are just using the application of the mean, where we are applying the mean. 0.5 is the yes, 0.5 you can say the average number of students who are received the average number of the students who received the accommodation. That is the weight we are taking here to the time. Okay. So the next class we will start the hypergeometric distribution and another distribution which is connected to the binomial distribution. So next class will be in the next Sunday. Please go through it all the information, because in this week We have done 3 classes, Monday, Saturday, and Sunday. Go through it. Any doubt, you can just drop a one mail to me and give me some time to make a question, one practice type of a sheet, so that you can do the questions. So 2 questions for each type of, you can say, each type of topic. I will just try to put it in there. Okay. Thank you all. Thank you so much. Have a good day ahead. Thank you. Thank you all.